On 200 acres in the Berkeley Hills overlooking San Francisco Bay, some of the world's top scientists are working at the frontiers of discovery. Welcome to the Berkeley National Laboratory, run by the University of California for the U.S. Department of Energy. What we do here is science that extends human knowledge and addresses human problems. None of it is classified. It ranges from the infinite, the shape of the whole universe, to the infinitesimal, the wispiest of subatomic particles. It all began in 1929 when a young professor at the University of California at Berkeley thought up a new way to accelerate atomic particles. His name was Ernest Orlando Lawrence. His invention was the cyclotron. It was just a few inches across. 2 years later, the university gave Lawrence a lab for his cyclotrons. Before long, they had grown too big to fit on campus. So he moved his laboratory into the hills. Today, Berkeley Lab employs 4,000 people and has a budget of almost $500 million. But it's not just the facility that bears his name that Dr. Lawrence left as a legacy. It's also a new approach to science that continues to thrive here at the lab today. Call it team science or interdependence. It binds the diversity of programs and people we have here at Berkeley Lab, creating an environment in which breakthrough research happens and wonderful discoveries are made.
I want to position the lab so it takes full advantage of its wide areas of excellence in physical sciences, in biology, in computational sciences, and engineering. The Advanced Light Source is an excellent example. It's a national synchrotron facility. It involves people who run the machine, operate the machine, ensure the safety of the machine and the users. But most of the users are individual groups, professors, their students. They team with the support base of the Advanced Light Source, that is to say the user support people, the staff scientists within the laboratory, to enable people to do things that they simply could not do in a lab setting. Lawrence Berkeley Lab scientists have discovered 14 new elements that have been added to the periodic table. In the history of the laboratory, 10 scientists have been awarded Nobel Prizes.
Our scientific teams look at the fundamentals of science in ways that not only help the country, but can also benefit our lives. For example, at the National Center for Electron Microscopy, researchers can watch the behavior of clumps of atoms no more than a few billionths of a meter wide, which may lead to stronger metal alloys and other high technology advances. Light is the key at the Advanced Light Source, which once housed Lawrence's 184-inch cyclotron. Here, magnets force electrons traveling at nearly the speed of light into a circular path, giving off light beams that are 1 billion times brighter than the sun. This allows teams of scientists to use those beams to find out more about the composition of materials, the structure of proteins, X-rays, solar cells, and the very air around us. Right now in our bioscience labs, we're blending robotic systems we've helped to engineer, new tools we've developed, and breakthrough ways of computing to find out more about the secrets of life itself. We've sequenced the whole genomes of creatures from sea squirts to pufferfish to poplar trees. We're learning the secrets of dozens of extraordinary microorganisms, knowledge that will help clean up pollution, create fuel from waste, defend against bioterrorism, and treat disease. Our engineers take an idea and make it happen, whether it's creating a new type of automated microscope or finding better ways to create an ergonomic chair. With one of the world's most powerful unclassified supercomputers, we've made simulation into an experimental science, global weather, deep geology, the heart of matter. With the Department of Energy's Science Grid, we can link scientists from around the world with instruments, computers, and databases, all doing science at the speed of the future. The future also brings the construction of the Molecular Foundry, a new centerpiece for collaborative nanoscience research to teach us more about molecular structure and create new materials that can lead to better and cleaner technology for economic growth and our environment. At the Lighting Lab, we've already come up with a more energy-efficient lamp. The Berkeley lamp is just one of the inventions here that explores new ways of using technology to improve the quality of life. In the skies above us, questions about the expansion of the universe and the dark energy that fills more than 2/3 of it. The plan, a collaborative effort to build a telescope, instrumentation, and satellite called Supernova Acceleration Probe, also known as SNAP. Its mission to gather data about dark energy that will show us where we've come from and where our universe might be headed. And here on Earth, concerned for the roles the lab plays in our own community, vigilant about being good stewards for the environment, offering educational services, licensing startup companies from ideas that germinate at the lab, and making sure that the genius for science takes practical shape in the safest possible way. Lawrence Berkeley National Lab is a unique and special place. We have relationships with the University of California at Berkeley and with other UC campuses and other institutions in the Bay Area and around the world, creating a synergy that puts us on the cutting edge of science.
Lawrence Berkeley Laboratory is arguably the best general-purpose national laboratory in the complex, but it's much more than that. It's adjacent to a truly great university, and I think we can combine the national facilities, the world-class national facilities, with interactions within the University of California system to create truly a unique laboratory. This means that we have both the talents of faculty, graduate students, postdocs, and even undergraduates, combined with national facilities, to come together in groups and teams to solve scientific problems that could not be solved by individual professors working with their groups.
Together, we can unravel the mysteries of the universe and improve the quality of our lives. We can go as far as our imaginations can reach.